Alrighty.
Well, obviously not, because we haven't had a microphone loopback yet.
What, you have a microphone? You don't have a microphone?
Well, usually when you go live, we start hearing ourselves 15 seconds back in time.
Oh, I see. Well, I muted the audio this time, so. Alright, so what order should I go through, Carol? You're the issue.
So I would finish first this thingy 442. We discussed it last time. There was some open question. I'm not sure if it's close to it.
442.
442.
Okay. SocketTask, yes.
How'd you get those badges?
There is a Chrome plugin you can install which does that.
Oh, is that Rocket ship up there?
No, that's Mercury Reader, I think. It's
okay.
this one,
Right.
one of those guys here.
Cool.
Like,
How does it see?
Nope. This one here.
Okay.
OSPO extension for GitHub. Open source programs office. Super cool. I see now who I can yell at offline. We should probably also have a patch specific for bad items. This is bad items, pay attention or something. Alright.
It's not on chat yet, so
No,
you're
it's
safe.
probably okay. Yeah. So I think this one was the controversial, if I want to say that. Like the design point here was, should we keep the extension class or should we move the extension methods, logically to the socket class and then effectively hide the SocketTaskExtensions. And we said last time that duplicating API service seems bad. Is there any value in moving things to the extension type, from the extension type to the instance type? And David Schulman said it's desirable, and then Stephen basically just said, well, if they're in the same assembly, you can do whatever you want anyway, because you basically have internal access to the other type, and today these types are already instance methods on the type, so whatever you want to do, you can do anyway. Just like the extension class basically just calls the instance methods today. So for all intents and purposes on the implementation side, they are exactly the same. Like there's no benefit to be had. I think to me, the more compelling argument would be if you want to expose it to the user, for example, making them virtual and allow them to derive from Socket or something, then I think that would make sense. But given that we don't have to do that today, I'm almost inclined to say let's just leave it on the extension type, and we get best of both worlds until we settle on a different path. Agreed. Steve, anything to add, or did I lose you again?
No, I'm here. I don't have anything to add. I'm fine with either option, so it's certainly easier to just stick with what we currently have.
Cool.
Is Socket sealed or unsealed?
It is. That's a good question. I don't think it's sealed.
It's being very slow. Emo.
What happened?
No, Jeremy. It's not sealed.
So the value in moving them to instance would be that we could make them virtual, and a derived type could replace the behavior.
Yeah, I have no design. I don't think anything is anything on Socket virtual other than just no. The only thing I think that's virtual is dispose.
Oh, all right. In that case, we may as well pretend it was sealed and leave things on the extensions class.
I guess the only benefit, and I don't think this is compelling enough, is from an IDE experience perspective, they'll show up as extensions rather than as instance methods, but I don't know if that's meaningful. And maybe from a help documentation perspective.
I mean, documentation I can kind of see, because documentation's extension methods are not ideal, but at the same time, I don't think it's substantial in one way or the other. Third option, I think. Yeah. Next one.
Before there's one more we previously talked about that I'd like to revisit briefly, if we could.
Yep.
Can you show me the list again that you had?
Yep.
It's 24115. So this seemed like a slam dunk, adding a sort overload that took a comparison instead of just taking the iCompare. Unfortunately, as Mike DN pointed out later on this thread, and as I hit when I tried to actually do it, null is a valid value for the compare. It just ends up using the default, which leads to an ambiguity if we add this overload. So I think that kills it, but I wanted to check.
If we had only non-nullable types.
Or if null was...
Or even arguably, if we threw, if like a lot of things where we throw if it's null, we could still argue that it was, it wouldn't be valid in real code. So, because it would have been thrown in production, so we could add it, but given that it's valid.
Well, but what I'm saying is, if we had non-nullable types, we could at least make the new comparer or comparison overload non-nullable.
Oh, sure, right.
The other one would just, if somebody passes null, it's clear that it's the overload that takes.
Yeah, that makes sense. The other thing would be if we had, the ability to specify, if the language allowed us to provide priorities, for overload resolution, but there's nothing like that.
Future requests for null pointer too.
Yeah.
I mean, we could add the feature by just rejiggering the parameter order.
Yeah, or we could add, instead of sorting an array, we could sort an array segment or something. But maybe, assuming we're adding sort overloads to span, maybe we just take care of it there and drop this.
That's fair.
We are adding sort to span, right?
Sorry?
We are adding like a sort extensions for span.
Well, that would be
so far nobody asked for that
issue to
I think last time we talked about it, the consumptionality as a result was spans are mostly bytes and nobody wants to sort them, but
wow. Nobody wants to sort spans?
Well, last time I asked for that function, somebody, I think it was you, who said like that never came up. So
show me the video.
I need to use some deep machine learning so I can index my videos and like point crystals to all the crimes you committed on me. Or me in that case. Yeah, that's unfortunate. Yeah, I guess then the answer is no.
I think so.
Yeah, hopefully when we add sorting to span, we add both options at the same time so that we avoid being able to use a literal null.
All right, next.
Right, so question from the audience, what extension do you use for those fancy names, full names, and key and that stuff?
Yeah, that's basically some extension that our open source programs office wrote. That's basically a Chrome add-in. So it just rewrites the HTML.
Is it available for public or just for
I don't think it is because I think you have to have permissions for the to be part of the.
I want that too, by the way.
I've just been searching their website and I can't find it.
No, I think it's one of those things that are hidden. You kind of have to like get the magic link or something. I will find it too.
So we have almost all span. So before we span with the span, let's do one more, which is younger, and that's 24575. Remember, you're up. Big integer, big endian. 24575. And then, Christoph, you can choose where you want to start with parsers and other span-like things.
Here we go. Big integer. Given that you asked for it, makes me think you want to use it for crypto.
Yeah.
Good.
I mean, like in particular, so in the binary encoding format of cryptographic structures, integers are always big endian. So it's because it's a wire format, so it's big endian.
Right.
And anytime that I'm doing anything where I have to read or write one of these, often it's even an unsigned big endian value, which means I need to allocate space to insert a padding byte and then reverse all the data, because our big integer class wants signed little endian values. And then if I'm taking a big integer and then going to write it down, I have to export it, reverse the data, trim off the padding byte, and deal with it that way. So it would be nice if we expose the two options of, do you want to read this signed or unsigned, and do you want to read it big endian or little endian?
So would it be better to just provide an API to reverse the bytes in the span?
That solves the big endian, little endian, assuming that I'm allowed, or assuming that I have a mutable span and not a read-only span, which I often don't want to have a mutable span. And but it doesn't solve the needing to insert a padding byte to get an unsigned representation. Like internally, it just means that this will read it backwards. So all that it does is change the direction of the flow. So this is faster than reversing all the data.
Right. So the reverse, you could do the reverse for try write bytes, but not for the constructor, and it would only handle the big endian and not the unsigned piece. Did I get that right?
Yeah. So the try write would write the padding byte, and then if you wanted to ignore it, you could then slice whichever direction on. But
you'd have to slice and then shift, or is the padding byte always at the end?
The padding byte is always the most significant byte. So big endian, it would be the leftmost, and little endian, it would be the rightmost.
Okay.
Memory goes from left to right.
Hmm?
Memory goes from left to right.
On the debugger, it does.
Everybody's head it does, unless you're really weird. Well, I guess you come from right to left. Can't from
Right.
front.
So in particular, I show, given a particular 2-byte value, there are 4 different numbers that can mean. And when you're going from a wire format into big integer, it's annoying to need to do all the mucking with the data beforehand in order to get big integer to give you the value you want.
So, to go back to Christoph's question, I'm not sure whether that's what he was asking for, but it seems to me that what we want to do in general is not have like an API surface where we sprinkle big endian, little endian all over the place. Like ideally what we would do is we would say we normalize to, I don't know, little endian in memory for the most part, because we know that's what most computers are. And then the only cases that we deal with big endian, little endian is when we deal with parsing wire formats, right? But that begs another question of whether we should just do it centrally in one place. Because they say the party that reads the spans, but they may have to call some reverse function and then call later APIs. We don't have to enlighten every single API in the framework with being able to read things in the reverse order, which seems reasonable.
Or we could have, so a week ago, we added some APIs to convert basic types from big endian, little endian spans. Maybe it should be a method on this type.
Well, I mean, we added read a span as a big endian unit 64, right?
Plus, Christoph, assuming Jeremy does want to use this in the crypto stuff, you're signing up to have that no longer be an OOB type.
Yeah, I know. I was thinking about this as well, but...
So, I mean, the problem with reversing the endianness of something is you have to have writable memory. So if you're only given readable memory, it's now a copy operation. Since we added the ability to parse along and tell the parser that this is read-only memory and it's big Indian, like this is just big long.
So what about instead of these methods being a constructor, it's some kind of a
static parse?
Yeah.
That's fine. I just went with this is the only thing that takes data input right now is the big integer constructor. I'm fine with it being static methods.
Maybe it's not worth to make it into a static.
It's for going purposes.
Yes.
It's just constructors we try to keep them kind of relatively simple, and this one is like, geez, what are all these things? Like, I don't even understand why you're asking me whether it's signed or unsigned.
I guess the argument is more like because the existing big integer one just happens to parse from a byte array already, right?
Yep. Given a constructor.
And Jeremy, the existing one just assumes signed?
The existing one assumes signed little endian.
Okay.
So if the most significant bit of the most significant byte is set, you're a negative number.
And how does the big integer know whether it's signed or unsigned? Is there like a flag somewhere?
What do you mean?
So maybe I kind of assumed something that is not correct. So I assume there's a byte array, and the most significant byte has two interpretations. It can be either signed, or if it's an unsigned number, it's basically most significant value.
From
byte.
what I've seen of looking at the class, it stores the byte representations and then has a side identifier of what's the sign, which is either an int or a long. And as long as things fit in the int or long, it doesn't use the byte array. So it cheats, and it's like, if it says -2, that means the value is -2. If it says -1, it has to go check and find out, is that actually a signed bit, or is that the representation of the number -1?
Okay.
Yeah, so I think it internally is storing things as unsigned and then has a hint of like, oh, I'm actually a signed number sitting on the side. Or if nothing else, it would just insert the padding byte itself when reading.
So I think in general that I can see that argument, especially for the read-only ones, which now means we should probably expose these APIs. We should just make sure that we do it in a consistent fashion. So do we usually use is BigEndian, or do we usually use is little endian?
Little endian, so
I went with is BigEndian so that false was the default.
So the endianness, I mean, we already have this concept, and like people kind of, people can read up on it. This is signed, unsigned bothers me actually more. Why? Because it leaks internal implementation.
No, this is only telling you how to parse it. It's not be an unsigned integer.
Yeah, I know.
It's parse this data as if it was an unsigned
But how does
integer.
the existing API work? Like, ignore little endian and big endian, right? I mean, like, conceptually, what you do for the existing one is you just pass in is BigEndian false. So how does it know whether it's signed or unsigned?
It's just how I think it's just how it's interpreting it. Correct me if I'm wrong, Jeremy, but if you give me, 4 bytes and you tell me I can interpret that as either an int or I can interpret that as a uint, right? And if I interpret it as an int, well then the most significant bit is basically whether it's signed or not, essentially. Right. And if I treat it as unsigned, it's just part of the number. I think this is just doing the same thing.
Yeah.
No, I get that. I'm saying, like, what does the existing constructor do that only accepts a byte array?
It is signed little endian. Sorry, it is signed little endian.
So it assumes it's signed.
Yeah. So my 2 parameters default values are the current, like, the falsiness is be what we currently do, which is unsigned little endian. Sorry, signed little.
Yeah. So I still say that this parameter tells the constructor how to interpret basically implementation detail of how it's, like what's the representation of the big integer.
It doesn't tell you anything about the internal implementation.
It tells you about the byte array, whether it's, how it should be interpreted.
how the parsing should be interpreted. Who cares how it's stored?
Fine, how the parsing should be interpreted.
Yes, that's what I'm trying to control. That's how the parsing is interpreted.
I mean, that assumes that now somebody, understands the format of the byte array as opposed to just treating it as a very long integer.
Is there anything special about the format? Isn't it just a very long integer?
It's just a very long integer. But just like we have long and U long, you can have a U longer and a longer.
I mean, would you advocate having like a U big integer as a separate type?
Well, that has problems if it doesn't understand how to wrap around. Yeah. How does it wrap around when you subtract a bigger number from it? Yeah. So this is like essentially the big integer parser. You can think of it as like if you're storing an int or a uint into a long. It's are you sign extending or not? Are you sign extending or zero padding? The number you're storing in is always a signed value. You're just telling it what the memory that you're pointing at, whether the signed bit is a signed bit or the signed bit is a number.
Yeah, I guess it's fine.
Essentially, there are 4 different blob formats that can be an integer.
Yeah, it just means in practice that when you want to serialize a big integer generically, you should basically use the existing API or basically pass in the, is unsigned to false if you want to not have to store this information separately. Otherwise, everybody has to know what it is, which seems not unusual.
Yeah, it's fine. I think the issue is that basically we have one type to represent both unsigned and assigned in this case.
Yeah.
Do we have anything for the byte array case? We don't have we have a Boolean parameter called negative. Byte array case, we don't have something that says anything about is signed or not.
Oh, I thought you added those APIs here as part of the proposal.
I only saw the span.
There, new overload. Oh, 2 byte array, sorry.
But we already have existing constructor that takes byte array, for example, that doesn't take into account signedness at all.
I mean, we can overload the byte if we want to, but since all byte arrays are interpretable as read-only span of bytes, it didn't seem like we needed another overload.
I was just trying to figure out whether or not why we didn't think we needed a signed bit before with the byte arrays.
For whatever reason, we've never needed it, and so in all of my code that I've had to deal with big integers, I always have to say new byte array of data I was given +1, copy stuff into it, reverse all the bytes, and then go parse that. And in our current era of don't throw crap at the GC if you don't need to, I'm saying this is the API, I need to stop doing that.
So the only thing that we should potentially consider is like, should we make is unsigned the first argument? Or do you think BigEndian is something more people care about? Like, I would generally assume people care more about the signed than they care about the
And then the order is the way that we would then say it of unsigned BigEndian integer.
Okay. So,
sorry, the order.
I think the natural English order would be this is an unsigned BigEndian integer.
I see.
So unsigned, I guess, should come first.
okay. So I have a question about the try write bytes. So we have many APIs like this in Cortex Lab, in some of the APIs that we will be discussing today. And they are almost the same signature, except the options are controlled with this type called parsed format. We even have an interface, iWritable, that basically has the same signature, except instead of is BigEndian and is unsigned, there would be a parameter called parsed format, and it controls the output. Should we change the signature to match?
I care about the functionality, not what it looks like.
So you're saying instead of having is BigEndian and is unsigned as individual strongly typed values, you would have a generic. How do you represent this? Like format? What's it called?
I'm confused, Christoph. I'm looking at parsed format, and it looks like its constructor takes a char and a byte.
I mean, you can. So it's basically parsed format is like a pre-parsed formatting string. So what we could do is, you know, uppercase B, lowercase b, uppercase L, lowercase l.
So what is B and L?
Big and little.
Oh, big and L.
And then just capital E and lowercase e.
And then the capital is the capital versus lowercase presumably is the sign bit.
Because then if you do this and we implement iWriteable at some point on BigInteger, it can be basically like trivially written to like text writers.
But when you only take one, how would you represent both of them?
What do you need?
Like as Steven just said, you accept one that takes a byte and a char.
Well, so there are two ways to construct. There are several ways to construct parsed format. Think about this as being just a char, because you can construct it from just a char.
Okay, but if you have a single char, then again, how would you represent two values?
Uppercase B, lowercase b.
So the first one was for the signed one?
Right. I think uppercase B is unsigned BigEndian. Lowercase b is signed BigEndian.
I don't know how you remember which one is signed and unsigned. That's not very good.
Just like with formatting strings, correct? Like you have to.
But that's usually used control casing. Which
You
is,
look up a table and that's the end.
uppercase B is uppercase format. Lowercase b is lowercase. That's natural. Signed versus
uppercase M is the month and lowercase m is the minute, I think.
Oh, okay. Well, all right. So it's not perfect.
For time span.
There are cracks.
Or not time span, but daytime. Yeah, I mean, I think that you know, personally, what I care more about is the functionality. You know, whatever. But
Just to make sure I understand Christoph's proposal. Christoph, you're basically suggesting we teach integer about new format strings that support both unsigned and signed, BigEndian and not, and then we change existing methods like toString with its format to process that, and we take essentially the equivalent of a format string to try write bytes, and also to BigInteger's constructor.
Correct. Well, not to the constructor. Constructor, I kind of don't care. It's just the method that writes the BigInteger. But maybe it's not worth it because it's for binary representation. I don't know.
But, I mean, it is a good point. Like, how would you represent the constructor and that thing?
The constructor is fine. That it's just parameters like this.
But don't you want to have symmetry between reading and writing?
It depends how often you write and what APIs you use. Do you use the raw API to write, or you use some higher level API?
Well, what do you do in other cases? Don't you have like the equivalent of a try write, a try read, or try parse that takes a format string? No, or formatting. No, formatting for you in your case is literally just encoding it as a string, right? It's not for bytes. Right?
Yeah. So there are basically there are two different methods. One writes binary format and one writes textual format.
I see.
The textual one takes additional parameter that, think about it, represents like an encoding or a culture.
I see.
But this is a binary. This is like a binary serialization. And these would not take the additional structure. They would just take span, bytes written, and then this parsed format.
Yeah, I don't have preferences here. Like, I mean, in general, like, regardless of the encoding, what bugs me a bit with formatting strings is that, as Jeremy said, you kind of have to look up a table. Like, you will not be able to write this by just looking at IntelliSense. Like, there's little hope. Like, unless we give you, like, a strongly typed field that says BigEndian signed, BigEndian unsigned, little endian unsigned, and then you just basically pick those guys, then I think it's a pain in the ass to do that. Versus these ones, I mean, it's possible to do it.
So I would only do it if, like, I assume that try write bytes is not very commonly used.
I mean, right now it's not used because it's spam. But
right now it's not used at all.
If you think that it's commonly used, we should leave it as such, and then implement explicitly the interface
Yeah.
that translates from the formatting strings to those.
Yeah, you're leaving the option open, so.
You can always edit, like it's Right.
The current 2-byte array on BigInteger looks like it's called approximately 60% of the time that somebody uses the BigInteger type. So 60% of the time that somebody uses a BigInteger, they want the bytes back.
Really? Wow.
According to APIs of .NET.
You always say that as if you're implying it's wrong. Maybe that's me reading into it.
I'm just saying the data I'm saying is limited by the accuracy of our telemetry. It's a qualified statement, not a disqualified statement. Yeah, and then if you missed it from the proposal, I was suggesting that we, instead of adding overloads to the span ones, that we just augment them because they haven't shipped yet. So that's replacing 2 of the methods and then adding the one for the 2-byte array.
Sorry,
Or I can make them overloads if we want.
What was the last one? You wanna?
So if you look, I commented the constructor and the try-write bytes that since we haven't shipped those methods yet, that instead of adding new overloads, we should just add the default parameters to the existing one. But to the 2-byte array, since that is already a shipped method, it needs to be an overload.
So 2-byte array and try-write bytes is kind of the equivalent. Correct?
Yeah, just whether you need to ask, whether it makes the memory for you or not.
Is there a way to determine how large is the span that you need for a byte for BigInteger?
Oh, there's count, but
I think Steve wrote something like that. When he had.
Hold on 1 second, let me check.
So would it actually make sense to just expose bytes property on BigInteger that returns the byte read-only span of bytes? And then you can copy it yourself.
Is it unsigned little endian, signed big endian? So no, it does not make sense because you're back to this existing.
Well, what
How you literally expose the implementation.
So let me ask this, does it make sense to expose a byte property off of int32?
I don't know. That one is different performance characteristics, I would say. That's the main reason.
Yeah, so if we don't want to edit things, I can add them as overloads, and if we, but I felt like just editing or augmenting the existing ones that we were adding for this release seems better.
So do you think that people would commonly use that 2-byte array instead of try-write bytes? Like, do we need to add both?
Well, if you need a byte array, arguably 2-byte array is much more convenient than 2-write bytes, right?
Yeah. That's why it depends how commonly.
I guess in crypto you probably mostly deal with byte arrays today, right? Or you actually have.
The stuff that this is relevant to, I'm mostly working with spans.
So you could do the other one.
But this is just the like.
In general, though, I mean, what I like about having this API is it just keeps the type symmetric, right? Because we already have these members on the type, so it seems odd to not add. Like everything that takes a byte array right now accepts the new flag, so everything that uses a byte array should probably also accept it, right?
You're saying that 2-byte array already exists?
Yes.
Yeah.
It just doesn't change the arguments.
Yes. 2-byte array exists with no parameters, which is why I said to add that one as an overload. And try-write bytes exists without the booleans.
So
I think we should just edit.
another one, should the try-write bytes be called copy too?
Try-write bytes is what we already checked in.
All right.
I mean, we haven't shipped it yet. We're free to rename it, but
I see.
And if we were to change that here, we'd change it everywhere we've added try-write bytes, which is a bunch of places. But we could if we prefer copy to. Right. In fact, I think copy to is what I initially proposed, but then we decided on try write bytes.
Right. Next. Carol?
Anything from span. So first off,
So we can do the first two, because they should be relatively quick. Because they are basically just overloads of like existing.
last words, something like that.
So SpanExtensions has 4 methods that are called starts with, and I think we should add corresponding ends with.
Why do we specialize byte with its own method?
Why we specialize? What? Sorry, I don't.
Yeah, it starts with a T and then starts with for span of byte.
Oh, it's just, I think Aston measured performance and there was a difference.
I believe it's that one of them uses vectorization.
Sorry, what was the answer? I couldn't hear Austin.
I believe like one of them information is vectorized, but I don't know.
But couldn't we? I mean, we could always specialize. If T is a value type, the JIT's going to specialize it anyway, so we could always just forward it to our own byte-based implementation internally. No.
I mean, you could do the if T is type of blah, or is type
Right.
of T is type of blah.
Yeah, I think that's
Yeah.
I know starts with is used.
Yeah.
It's used in like Kestrel parser. It's so performance sensitive. I would really not touch the byte one.
Oh, but there shouldn't be any difference whatsoever.
How cannot be? There cannot be any difference. The implementation is different.
No, what he's saying is that if you write a method today, right, the JIT has to specialize for a value type. So what we've done in our SIMD stuff is we have said, like the add method that is generic says, if T is type of byte, here's your code. Else, if T is type of this code. And then the JIT is smart enough to kill all the other branches, and then effectively you are left with your specialization. So you can do whatever you want to do, essentially, if you want to specialize. The only case where that doesn't work is if it's reference types. Because if you do that with reference types, then you end up with like duplicated code because the JIT cannot actually do that because it keeps just one implementation alive.
Well, if we can, measure that there is no performance difference between these two, then it's fine. I mean, there's also the constraint to I equatable. I see the branch with byte would just ignore it.
Yeah, because you know that byte is equatable.
Yeah, I mean, if there's no performance difference, then sure. I just thought that.
You could just look at the assembly code and tell you that isn't a difference.
So for the performance, what kind of measurements do we have? Like, is it like on someone's machine, or did we do like bigger investigations and things? Like especially when we're adding APIs. Yeah, that's what I've seen those cases. So just
Awesome.
We have the general test showing up in BenchView for fastback.
okay, so it's on the per flop. Okay, cool. That's what I wanted. That's the answer I wanted to hear. Great. Get ahead of me. I like it.
My general feedback would be if we already have existing methods like this where we have byte specializations in addition to the T overloads, we should maybe revisit them and get rid of the byte ones if we can.
Sure, we should.
Like besides cleanliness, is there any other benefit by removing them?
Well, it's half the methods.
Sure, but there's no. I mean, performance-wise, it makes no difference. It's a bit more noise than IntelliSense, right? It works.
IntelliSense, docs, code maintenance, etc., etc.
Yeah, the only thing that I remember when you do these kind of tricks is like you have to be careful where you put your methods, which means if we do what Steven suggests, then we don't have that problem. So, for example, everything that takes a generic has to be an extension method, effectively, because otherwise you don't get to specialize it necessarily, depending on what your entry point is. But actually, I think when they're both on the same thing, they actually work. Anyway, yeah. Any other concerns though? Otherwise it looks good, right? I mean, if we have starts, then we should probably have ends with. Seems reasonable.
And
I don't see the APIs proposed there. You know, there's formatting.
Christoph filled out the form wrong again.
Oh, you're saying that I should rename the starts with to ends with? Okay, yeah. Okay, good.
It's true. Also, where's your scenario write-up? I don't understand.
What else do you want me to write up?
How will you use the APIs?
Can you give some sample inputs and outputs?
Also, can you? Oh, never mind. I just answered my own question. I was going to ask why we have both span and read-only span, but it's because these are extensions and it won't get resolved otherwise because it doesn't consider implicit casts. Is that right?
yes. Yeah, for the consider removing all this span of byte things, I think we should have a separate issue because it's like a cross-cutting cleanup, not specific to this one. But
And remind me again why we used them as extension. Was that thing that Jan was saying that if you make them extension methods, the benefit is we have generic methods rather than generic types, which gives us the freedom to only basically generate the code for the methods that are actually instantiated with, rather than the instance method. We always have to do all of them.
Right.
Okay. So that means you never get to making them instance methods regardless of what we do.
Well, unless we want to pay the cost of jitting everything.
Right. And for the byte specific ones, they would have to be extension methods, but for the T, theoretically, they wouldn't have to be.
Alright. Actually, no. Forgot the really important part here.
Whereas here I renamed the methods. So
Good. So we have index of, and we don't have last index of.
correct.
Holy shit, that's a lot of methods for an index of.
So we've got, so can you help clarify what these categorizations are here, Christoph? So there's last index of any for byte, but not for T?
Yeah, so basically I copied and pasted the index of methods from span extensions and then added last in front of them. But it's a good question, like should we have you know, the last index of any and the index of any that take T's.
Again, I guess this goes to the cross-cutting thing, but again, it'd be great if we could avoid the specialized ones and just have the T-based ones.
Do we actually have efficient implementations for all of them? It seems like hard to believe almost.
Also, do you remember whether the last index of NA are
No.
factorized? No.
Well, the index of any is,
Yeah.
so I would assume last index of any is also true.
Well, so, sorry, index of is the one that takes bytes, but I wonder whether the of any is vectorized.
How do you do
Because I don't even know how you can implement vectorized.
You just make 2 or 3 different vectors and do comparisons against all of them.
Yeah, you kind of have to like do it 3 times.
So why don't we have a last index of that takes a T?
That's, I think, what we
We
just
have last-
over the phone.
We have last index of T, but not last index of any T.
Yeah.
And that was Steve's question. Okay. That's what I mean, yeah. Because I just tried to clean them up here and it's resulted in not having any methods.
So should we, what do people think? Should we add last index of any that takes T?
I mean,
we
why
thought
not?
it was useful for byte.
Okay.
What if it went?
And then we do
Index
the
of
same thing.
any
We do
short?
the cross-cutting thing, basically look at the implementation, whether they can be collapsed. and measure perf. Okay.
Yeah, if the JIT's doing its job, it shouldn't even come down to measuring perf. The ASM should be identical.
Sure.
And this would result in basically that, right? Does that sound right? The verb will come with just with keys.
No, I mean, you seem to have a syntax error on line 8.
I think you need to add the constraint to all of them.
Yeah.
Sorry, what was it?
The constraint needs to be
Where T is a struct and I equate
Oh,
It has to be a struct.
because you cannot actually have a span of
you can't have a you can't have a span of a ref type.
You can have span of it. Of course.
Alright, well, then I don't get it.
You can do a span of.
You do a span of object?
Yeah, totally. Or just like
Because really it's just a span of pointers.
Items can be whatever they. Yeah.
So why is the struct constraint there?
That's actually also a good question. Awesome.
Need some big time?
I'm not sure.
You ended it.
No, it was Ben and Ben added the whole other new added it.
He's silent.
Ari, you checked in the code.
Oh, the blame
in the code.
blame game. Cool.
Does it have to be with equality?
yeah, it should have equitable.
No, I mean, like, is it because we don't have a good equality on reference? Like, if T is a reference type? Performative equality, I mean.
I mean, the default equality operation for reference types is address equality.
Okay.
Right, action item. We need to remove that constraint. At least one of them.
API review. We're rewriting this entire time.
It does.
Christoph poked the bear.
So does index of any also have that struct constraint? I guess I should actually go look at the code.
Yes.
Okay, so we should consider removing it there too.
Wait, actually it doesn't. Index of any doesn't have that structure.
Index of any says byte. It's not. It wasn't. Index of any wasn't generic.
You don't have index of any T. APIs. Of
It was
.NET.
already.
right.
There was
Yeah,
only
it's
the
not-
byte option.
Exactly.
So T is always an equatable structure because it's byte.
Yeah, but you have it on index of.
Yeah, I copied and pasted the APIs from the ref. DLL.
Yeah, because.
We'll just decide this for the end.
So do we need some kind of reconciliation of all the existing bytes and what makes sense, what does not?
Yeah, so we just said like we would do.
Not only these, but,
we would
yeah.
do a review. I mean, experiment whether JIT can deal with the not having the byte overloads, and then second one is just remove the constraints, the struct constraints.
Yeah, they may have just copied them from the as bytes, which presumably takes a struct because that's the only way that we're guaranteeing what the memory looks like.
Yeah, and some of the bleating methods have a constraint.
No, yeah, because like starts with even has the where T is a struct. The only thing that doesn't, as span and copy to, are the only things on here that are generic that don't have the T must be a struct.
API needs work.
Yes.
Come on, just remove the constraint.
Well, if it compiles afterwards.
It's fine.
Alright, next one.
Which one do we want to do? Awesome, Adi.
Basically 4, or I guess we can do Addies.
You had basic for last week.
Yeah, so that's why let's do Addies.
Yeah.
Okay.
What is Eddie's one?
The top one.
First.
Yep.
And there goes the meeting.
Yeah, I mean,
Don't we have a second hour?
yeah, I just have a conflict during the second.
Well, I think that Stephen just fast forwarded to the end of this discussion. So.
Yeah, well,
Well, you said there goes the meeting, Stephen. That's why you dropped out.
Yeah, it was telling the future.
You were mean to the roundtable. I think it's not a problem with my USB driver. It's a problem with the attendee. I mean, that's what the problem is.
Mm-hmm. All right, I'll apologize.
So what's the? Oh, this is the parse format thing, right?
Well, the parse format is
the same
kind
one,
of first on the list, but we should start with the parser and formatter types.
Oh, well,
Because otherwise
same, but
it's
then it's the
hard.
thing we just mentioned.
Yeah.
At the same time.
The UTF-8 parser, the char format equals null?
Yeah, I think it's the default of char probably.
Is the format supposed to be the parsed format, or?
Yeah.
No.
So, Adi, why did you change the parse?
Well, for parsing, the precision doesn't play any role in it.
I see.
So, I split.
So why is the format char, or what's?
Because parse format is a char plus an optional precision. And since precision is meaningless when parsing, the only thing that's left is a char.
Let's see.
Yeah. I still don't follow. So what's the char then? What's the value? What are the values?
G, D, N, X.
Oh, that's those things.
Yes,
I see.
the format.
Okay, fair enough. Formats, right? And default should be?
Default generally should be what is a default on the classic two-string APIs.
We need to update it over there, right? So the default over there is null in the UTF-8 parser.
Right.
That's not going to work, right?
Why not?
Char is, like, isn't it?
It's not great style, but it's legal syntax. I think you can at least say null as
a zero.
Substitute zero.
Oh. Okay, fair enough.
Bad style. I won't do it in the actual code, but
it's
legal.
I didn't know that actually.
Yeah. Default would be cleaner.
Yes.
Especially that now we have this awesome syntax in C#. You can just say default.
Yeah. So
you don't have to say default open parentheses, then the type name repeated.
Try parse byte, is that reading hex?
Sorry?
Try parse byte, is that hex reading? Like FF, or?
If you pass X as the format, yeah.
Otherwise it's reading it as decimal?
Yes.
Are all the format strings really only a single character?
Yeah, they are. Yeah.
So one question I have: should the read-only span byte parameter be called UTF-8 bytes? So it's clear. I know it says it in the type name.
I don't know what to say, like at that point.
Which one again?
So UTF-8 parser, all the methods start with parameter is bytes. They need to be UTF-8 text.
Yeah, because I would just call them bytes, not text, but yeah.
Well, I think you want to have text in there because bytes is a representation, but text is the semantic.
Yeah, I guess that's fair.
Can I ask a follow-up on Wes's question? So I don't know that it's true. Well, with the existing parse methods on types like timespan, it's not true that format is only ever one char. So are we doing only a subset here?
We are doing only a subset, yeah. Which format is the multi-letter one?
Anything where you specify like just month, like percent %s or m.
A datetime format, for example.
You mean custom formats?
Yes. Custom.
Yeah. Custom formats are considered out of scope for this API.
Well, also we don't have custom formats for ints.
But you're parsing date times in here too.
Oh, okay. Yeah.
And time span. And GUID. Although GUID I don't think has any custom ones.
Yeah, how do you parse the date time? Like, what format do you use?
There's several.
Exactly.
There's actually, I think there we follow the behavior of datetime parse exact, which actually takes a format string.
That takes a full string.
Yeah, and
This one only takes a chart, so like you would have to.
yeah, we're not supporting custom formats.
So if that's the case, should format be standard format or something that makes it clear, or we think that's just understood?
And we're not doing it today, but I expect we're going to do it tomorrow at some point.
We could add, later we can add an overload that does custom formats if we want.
Is there any benefit of not taking a string today? I mean, there are no allocations, right? Like you call this guy once, right?
There is. I mean, even if you have a literal, there's some cost of having a literal and then copy to a string, create a string, copy.
What?
There's a cost. Even for literals, there's cost. Literal strings.
Yeah, so difference if taking string versus char is like there's no difference basically. That's what you're saying.
No, there is a difference. Char is just we pass 2 bytes to the method. String, literal, we have to get the runtime field, which has the data in the metadata, and then we have to create a string and copy it into the string. And have a string on the heap.
But will it be worse if you end up having to support string later? Now I have string and char, 2 fields in this struct.
No, it's not a struct. We would basically just add an overload to the try parse method that takes a string.
Why wouldn't you? So you wouldn't go through parsed format then at that point?
For the we are discussing parse or format.
The parse.
Yeah.
So you wouldn't use parse format anymore. You'd have an overload that takes a string.
They don't use parse format today.
Yeah. Okay.
We would just add an overload that instead of the char, it takes a string. So if you want to pass a string, you can. And now it allows you to do custom formats.
Do we really anticipate custom formats? Because these APIs are for sort of to the metal performance, not convenience.
I think for date times we're going to probably end up having to, or these things won't be very useful. But.
Yeah, I think for primitive types nobody cares, but yeah, daytime seems like a likely candidate where you need to support more eventually. Like for example, XML has a specific representation, right? I mean, like if I want to do a high performance XML parser, right? Like
do we need datetime today?
We do need, because it's part of like HTTP.
Okay.
Headers.
So right now, I think you're only caring about the RFC formats.
And we basically need to support the default, the RFC format, and that's it, correct? Yeah.
I mean, even if you have to extend the set, I mean, you could start with not doing the custom format string, but just adding another character to the set of things we understand, right? We could just, let's say we don't support XML, we would add the xlet rule to mean the XML standard.
So can I ask, I totally could buy that methods like try parse byte and try parse int32 could be impacted perfwise by a string instead of a char parameter, but date time and time span, parsing those is so relatively expensive. Does the string versus char actually matter?
We could measure that, but honestly, I would even start with, I'm not even sure whether we will ever support custom formats for this. Like, once you get into custom formats, then you have like an order of magnitude performance hit. And I'm not even sure we...
So as long as we don't back ourselves into a corner where we can't support them, because
I said we don't, because we just had an overload that takes a string.
That's what I'm saying. We just need to have an out, so that I suspect we can never say we never will support them, because we probably will.
Well, I would suspect the first thing we would do is we would just add to the list of char formats you can pass in. Right? Mm-hmm. I mean, I think that would be the most targeted fix about requiring like new APIs, right? And then if RFC format for that, then sure, maybe we add the custom formats. But you could start with something smaller. And I'm losing my patience again. See, we need to be nicer. roundtable keeps kicking you out.
What's our behavior if you pass an unknown format and we throw?
Unknown or unsupported formats throw, yes.
Yeah, okay.
Yeah, that allows us to add new formats in the future. Otherwise, we cannot add new formats in the future.
Yeah, that makes sense.
But you could just return false, right?
But this is like an invalid argument.
This is programming error, not...
Yeah. No, I'm fine with throwing. I'm just saying you could do... Jesus fucking Christ.
Yes.
Oh, it's dropping Steve all the time?
Yes, now it's doing it on
Just Steve? Because I think our video is frozen.
Well, that's normal. Every time the roundtable resets, that's what's happening.
Yep.
I was willing to give you the benefit of the doubt, Emo, that it was the round table, but now I think you're just messing with me.
Yeah, that's... Apparently there's another person in me, because it also messes with me, apparently.
He's like a kitten. Here's the bottom.
So then, given that, any concerns with the general API shape?
Looks like you've hit every single struct except for system.char, which is not specified.
Why?
Because system.char is a UTF-16 parameter, and you're reading UTF-8. Like it just kind of on its face doesn't make sense. It's not an integer like a byte or an 16 is. It's
formatting kind of would make sense, but parsing not really.
It's a 1 byte UTF-8.
You can always add in the future if there's a need.
Yeah.
So I'm really struggling to think of a scenario where I'm going like that. But you've hit everything else.
We also don't have string, right, which kind of makes sense.
Because when do you stop parsing for the string?
Zero. Later.
Yeah. It's called UTF-8 encoder.
Yeah. So we used to have nested types, right? Now we basically make them 2 top-level types. Is it?
Yeah, because the nested types, I was just showing it to, I think, Asan or Levi last week. Visual Studio literally cannot deal with types that are nested and have names that are similar to namespaces. It was just such a mess. Also, one suggestion that somebody had, we were discussing the name of the parsed format type, and Ari had a suggestion to rename it to buffer format. We kind of that they like the parsed format is used in parsing and formatting APIs, and it's confusing because people think that it's related to the action of parsing, but it's basically that the format is pre-parsed. It has nothing to do with the operation. So Ari suggested that we it basically specifies in which format the buffer ends up being.
I like the suggestion from earlier where we just call it standard format as opposed to custom format.
Yeah. I like it.
Yeah. Sounds good.
Okay.
Yeah. Alright.
Is it really the standard?
Well, it's like
it's one of
standard
ours.
implies it's an arbitrary set that we standardize, right? At some point you will have standard format 2.0.
In that standard 2.0.
Well, yeah.
Of course. Otherwise it don't make sense. Where are these?
So I'm slower. Where did Stephen suggest that at all?
He was said it. He just verbally said it.
Yeah, he said it like earlier, like a few months ago. He was talking about the parameter, not the type, but it's doing the same thing.
Did you kick him out, or is he still online?
No,
I came back. Emo tried to get rid of me again, but failed.
Yeah. So the parse doesn't really need the precision in any case?
That's what Ari said.
You're delegating. I'm just trying to think of a case, but I'm...
Yeah, I haven't. mean,
One thing that always bugs me about our APIs is that's just the way C# works, is that we have one name for when we take an argument, and then we have multiple names and we return the same value, because we cannot overload based on return types, right? It's the same here. I really dislike that symmetry, but like we have it all over the place, so it is what it is.
So I know, what's the behavior on parsing integrals? You go until the end of the span, or you go until you hit a non-digit?
Yeah. Until you get non-digit.
Yeah.
You would never have a case where you have a decimal followed by an integer that were connected together in the buffer, though? That you would need the precision?
You need to know where the thing is.
Where's the
comma or something?
I mean, if you knew you always had a 2-digit number, but then you have an integer following you.
With no separator?
Two. Yeah.
Slice the damn span before you pass it in.
Yeah, then you slice. Yeah. You can always.
Yeah. That is.
In binary format, you don't have that problem, right? Because it's just bytes followed after bytes.
So 0 with white space, obviously.
Yeah, 0 white space delimiter. Exactly.
You owe me.
Is there a reason why we chose 99 as the max precision? Is there a particular spec or something that says this is like the max we're going to go?
I don't remember now, but I think the reason was that this is the max precision in .NET in CLR for formatting.
That's true. I don't know if that's why we chose it, but that's a true statement.
Cool. What's the behavior if you look at the precision property if it hasn't been specified? Does it grow? Does it return?
It returns no precision internally 255, which is a distinct thing from 0.
So you can always check for that separately.
Yes.
Is default is check to see if it's null? Is that right?
Is default checks to see if it's the default struct.
It's basically the char is 0 and the precision is 0.
Yeah.
It's just a very convenient helper because in many methods the first thing you do is you check whether it's the default format.
You have the same on mutable, right?
So is it more efficient than doing default of parse format for you?
Compare, yes.
Is it? Really? I don't understand why.
Because unless you implement equatable and all of that bullshit, like you get the default implementation of CLR, which is not that good for structs.
But presumably wouldn't this implement equatable in others?
Well, we could, but then also writing the code is just ugly, right? You have to you say, I mean, now with default maybe it's not too bad, but you used to say, some variable double equals default of whatever the type name is. I mean, in this case it's also non-generic. It would really suck in immutable array because we didn't have the shorthand for default.
Oh, sure.
And you had to specify the generic type.
So
and we just default.
Yeah. I actually think that it will be more expensive because basically what will happen is the default value will have to be created, which is char and a precision.
Yeah.
Then you will have 2 structs. They possibly have padding, so they are even larger than one machine word, or no?
Should be 4 bytes, right?
Or maybe it should be just 4 bytes.
Yeah.
And then you pass them to this method.
Well, does it make sense for this thing to have equatable on it as an interface?
Oh, yeah.
We should probably do that.
Yeah.
I assume that format equals null. The shorthand for format equals default of parse format, really, because it's not really going to be null. Right?
Yes. It's a valid, but
so we're always
going
to
nice
even for structs it's valid.
Yeah, it's allowed.
Oh, that compiles.
It compiles.
I'm
apparently.
surprised it compiles too.
Yeah. He probably shouldn't compile, but it does.
You're playing fast and loose these days.
I think I know why it's compiling. Because char, as you said, char, I can believe that can be, null can be assigned to char, which results in that just 0. And then there's implicit cast from char to parse format. Otherwise, it wouldn't compile.
Oh.
I mean, it would be very strange if you could just assign the null to a char.
You have an implicit cast from the
I'm not going to code it that way in the actual code. Consider this a typo in the review.
Yeah, the implicit cast is super convenient. Because in most cases you don't pass the precision, and then you can just pass, you can say try format, some value, buffer, bytes written, D or X.
Okay, but like, sure. But the question really is, like, should we not have, like, effectively MSDN tables in code? MSDN tables. So on MSDN, there will be a table that says, this letter means this, right?
Yeah.
I was also asking, we're really trying to make this as absolutely streamlined and efficient as possible. Wouldn't we want to encourage folks to do the parsed format once rather than, spending a few extra instructions to create it each time?
Yeah.
If you care about that level of detail, because parse format that if it had to like actually parse the string, that's kind of expensive. But like if you the implicit operator, I mean it just assigns the char to the field.
It seems to me like what I rather would like is like a field that tells me what it means and that returns a parsed format.
So are you saying like a parsed formats class that just has a bunch of static parsed format instances?
Right.
Well,
it
no,
doesn't
but
make sense for like
no, they have different meanings.
Why?
That's how formats work. Like depending on the data type, they have different meanings. Yeah.
But
no, sure, but you could have. I mean, like, what the primitives support, right? You could have like in32 blah, in32 blah, in32 blah, right? Like, I mean,
logical descriptions basically.
Yeah, so. In 32 decimal, in 32 hex, and so on. But that's like you can always add that later, though I don't see how it affects this review.
No, because if you do that, then I think the char overload is not as convenient anymore because I'd rather pass in the existing thing because that's the thing I want, right?
No, the char overload is so convenient. I mean,
really compared to like pass format dot
exactly
well-known thing.
Yeah. The well-known thing is, like, what would it be? All the letters?
Well, I mean, it's not that we support every single letter in the universe, but it's a pretty finite set of, like, 10 people that take 10 things, right?
So, for instance, one of the parsed format, like, well-known statics could be parsed format.datetime RFC format, and another one could be, like, parsed format.RFC float format, and maybe they're both represented as R, so maybe they're both actually the same thing, but you pass whichever one linguistically makes sense for your application.
For some of the like well-known, maybe it could make sense, but I think there are like
maybe, but I mean, I don't know, like maybe it's just me, but if I read code and I see a magic literal that I have no idea what it means, I don't even know how to look it up either.
Yeah, but
you're not googling for a single letter thing either.
Sometimes the magic literal does make sense. So, like if you have if you're formatting an int and you pass an x, like it's pretty well understood that's x.
Right. We have this precedent in the ECL, so
yeah, we have it all over the place.
We've kind of created that language already, for better or worse.
So I'm using .NET for like 15 years. I can never remember the format strings, but like maybe that's just me.
Yeah.
No, for daytime I just say y dash.
I remember the subset that I use.
But this problem is not, except for the well-known, like the RFC for daytime, the constants would not solve your problem anymore, because they would be parse format.d.
Well, I mean, we can name this guy, right?
What would we name it?
You would name it
what would we name it?
Integer decimal.
For example.
Which is a horrible name.
You give it a sensible name, right?
Like,
the question is, have the letters become the name in the public knowledge? And I don't know how to answer that. The letters are already kind of embedded in people's minds, and they are effectively the name.
And this is advanced API.
I don't think they're embedded in anyone's mind. I think everyone has to go look them up.
Yeah, exactly. But we at least have a well-written table now.
Which also, I challenge you to find an MSDN without.
I know how to
I just found it.
You need a special technique. You need it's a special query in search engines. Number formats. MSDN.
Alright, anything else? Otherwise we keep backshitting over format strings now. It seems like the only feedback we had so far, I think, was rename parse format to standard format, implement IEquatable.
What do you get from that?
Just general correct behavior, because if you compare two parse format strings right now, it will be horribly inefficient if you do that.
Yeah.
Maybe it's covered at the top part. We talk about where this is going. Which assembly this
goes in? Yeah. So I think I need to leave now. Like it seems like a painful discussion.
It's going for now. It's going to the same SMP where we are putting all these APIs, like the basics.
This is system buffers.
System memory.
System memory.
While we were chatting, Ben already proposed a new API.
Which type and use overloads?
Like type in the name.
I don't see what he did now.
Oh, he wants to take the. I don't know. I don't even like it that try format doesn't include type names. To be honest, I just like to be more explicit.
But that is an inconsistency we should think about.
Yeah.
Oh, because you. Oh, I see.
Yeah.
So you basically. I see. Well, that's basically what I said earlier. Yeah. In this case, you could get away with it because you don't return it, right? You actually have an out argument, so the compiler can actually help you.
I don't know. In some sense, personally, I like to make my intentions explicit. I come back to the binary writer example, which I absolutely hate that API because it has 10 overloaded methods all named right, and I have to add an explicit cast to just make sure my intentions are honored. That's where I'm coming from. That's one of my pet peeves. So
we not do the same thing with try format then?
Yeah.
So the try format one also taken the type in its name.
Yeah, that would be my preference.
Yeah, for the things that take out, I could go either way because the compiler will not allow any implicit cast, right? So like you make your intent explicit by.
Hopefully that will always be the case.
That being said, I mean you could do out var, in which case the compiler is like, well, now I have no idea to know what you want to do, so you specify the type.
Fewer bars in the world, I'm happier, but not enough of a reason.
5 letters into 32 somewhere, just later in the parameter name or
my killer level is low. I mean, like I would honestly say, like going with the type names in the method names makes it more symmetric to the existing binary reader APIs that we have or stream reader APIs. But I think it will never look beautiful because of all the auto arguments, right? So like it's not going to be a very short signature.
Now with the new inline syntax, it's actually quite nice. I started to like out parameters.
Yeah.
To a point that I don't use tuples anymore. Because I have to add a package.
Yeah, that's true.
So to your point, should we rename try format and add the type names to it?
Sorry, which ones?
Try format APIs to match what try parse has.
Yeah, which way are we going to go?
Well, I mean, like the existing binary reader APIs, because they return values, they basically just say write, and then they accept the value.
Right.
But they say read XXX.
Yeah.
And so this would match that.
But this
and as I've said, I hate the fact that binary writer did it that way.
Yes, like so I'm saying, like from my point of view, like I can go either way. I would find it very odd if you would put type names everywhere and try format, because that's very unusual. We don't do this usually. We usually rely on overloading to do that. For outs, I don't think we do this a lot to rely on that for overloading. But I would honestly, if somebody would propose this API, I wouldn't say no to it. To me, that makes as much sense as the one that Eddie proposed. It's like, it's just what do you favor? Do you favor the consistency or the consistency? Maybe the wrong word, but like make it very equivalent to what we already have, or do you favor the shorter type names? Like I think they are both equivalent. I don't have.
Yeah, so I'm with Ari that I like the explicitness for parsing, but I also like symmetry between parsings. So I'm on the fence.
I don't really care about the symmetry, to be honest, because you already have the data to write out, so why do you have to say, again, this data is in 32 as opposed to in 16 or whatever?
Oh yeah, if we, yeah, that's the negative of, if there was no negative of getting symmetry, then
Well, that's the same with the parse. You're getting out parameter for the values.
Well, I can tell you where I got fucked. Like, I mean, it's usually for integer size values where you do some arithmetic operation and suddenly the thing is outcasted to an int, you write out each other.
Right.
Like that's the thing where.
Right.
Versus with like on the bottom one, like it's physically impossible to get fucked by that because you literally specify a storage location, right? And like you already typed the variable, so there's no implicit conversions. I mean, following that argument, it's actually more beneficial to rename the first one than the second.
That's what I want the compiler to act as a check, not as something that changes things underneath me.
Yeah.
Well, you're never going to get upcasting in the first case because you provided an overload every single time.
Right. Yes, but let's say I have a variable of type byte.
Yeah.
So I write the type, right, and then I do like
so
byte plus 10, and then
Yeah.
suddenly you're like, oh, no, we're writing it in, not a byte anymore, because that's what the compiler does, right? And that is surprising, right? I mean, I had the same with floats and doubles where, I wasn't really following what types I use for floating point, and then the format required a double and I wrote a float, right? And then
yeah, so that's actually a good point, Ari. For the parse overloads, there's no way to screw up. Because the out parameter, you have to specify it.
Right.
Sure. It only prevents you from using var, but I mean.
Well, one could argue that you're not going to screw up.
That's what you don't want.
Yeah. That's a positive in my book.
So let's remove this
So
aspect.
one would argue that you won't screw up with try-format either, because byte plus 30, if it happens to fit into a byte, like it will still write out a value between 0 and 255. If it doesn't.
Well, I mean that's true. That makes it a little bit different from the binary writer example where you absolutely don't want to change the size usually. So that's sort of the mitigation to my argument that says it's not so bad when you're formatting text. Right. It's a valid point.
All right, let's remove that. Let's go with Ben's
And
suggestion.
you keep these as overloads.
Yeah.
Okay.
All right.
You've been heard, Ben.
I mean, if you say try parse for byte today, and the text is like 2553, do we return successfully with 255, or do we throw, or return false, or whatever?
I thought you returned false.
We will return false, yeah. And that's an overflow underflow situation, which we do actually flag as an error.
Yeah.
We don't treat the 3 as this is a weird delimiter.
Basically, you go until you hit a non-digit.
That's right.
And then everything up until then you try to make that.
That's right.
Okay.
Alright, anything else? I think that was the feedback, right?
Is the rename also the argument to standard format, or does it not matter?
Yeah.
So it's the type.
Well,
the parameter name?
Yeah.
I have no
take a
preference.
star, it kind of seems beneficial, but I would bend and do it. I mean, it seems a bit superfluous because I think it's fine to have the suffix name of the type. But yeah, I can go either way on that one. I mean, what is true is that when you display them like this, you would like to have symmetry between these two, but in practice you don't care because you only look at overloads within that set and only with overloads within that set, right? So what's more important is like that this name here makes sense to you.
Yeah.
So to me, like standard format here seems sensible.
Yeah.
And when the default is passed, we use the same defaults as the built-in types do.
Yeah, that's good.
Yeah.
How bad would it be if we just made it be standard format instead of char here too, just for completeness?
And just document that precision is just ignored.
Yeah.
It's not horrible in my.
It just lets people pass precision, and they may wonder what it means, and it has no meaning.
Such as I'll only read up to 4 digits and then I'll stop if I pass X4.
Right. That's not what we intend to do. So.
But if you're going to start storing like constants of my format, I'm going to have to store them as 2 different things, or call the parse format.char or something when I call it.
Well, you wouldn't be able to store a constant where precision is involved because, you'd have 99 different constants.
No, but you may have it's actually, I do have constants, for example, in like the GWT formatting, correct? Because the individual items of a GWT are formatted using D2 and D4.
But for char, having constants doesn't make sense. Because char is, literal char
No,
is...
but if I know my data I'm reading and writing is going to be of this type format, I'm just going to...
Yeah, you want to be able to use, I get it.
And a few or stacking constant somewhere, and then I can use it in my both places. But I'll have to store char or hardcode to char everywhere I parse, or call it.
Is it possible to do add an implicit cast from standard format to car? Or does that have to be done on the car type?
On UI, should we rename the formats on both to standard format? Like, so people can go to documentation, like, basically.
The overload already is, like, the type is called standard format, right?
I mean, but I think here it adds less value than here.
Okay.
But I mean, like, you could do it on both types.
I
just don't care what you call it here because I think format is fine.
It's actually good.
No, but like to your case, I mean, you can just say, you know, you're
yeah, you can just get a symbol that way. That's what I was saying too.
So you just want to go create a client website just for user comparison. Assuming we have this.
Well, I mean, like if you write your own stuff, right, you probably want to use the same format for reading and writing, right, so you don't fuck yourself. Yeah. So you would probably declare your own constant for that. Alright. Okay. That was easy. So then we just improve the API.
Stephen was wrong.
Huh? Well, we haven't talked about the assembly name yet. So that's entirely wrong.
Did we change it to the standard format or not?
Yes. So the assembly name is system memory, correct?
So this is where everything is going right now, right?
We decided to put all of, we already had this discussion.
Yeah.
We for now put them all in system memory, and then we need to have a separate meeting where we can decide whether to make
bring out the gloves.
Where we can make it, whether we make it basically into permanent loop, and then we invent a new assembly, and it's permanent loop assembly.
System.perma. Oh.
System perma oops from July 2018.
Perma oops is oops from in the years 2010 to 2015. Don't sign it.
That's when it's permanent.
That's not how that works.
Base 64. Ari, you don't want to listen to Base 64 discussions?
By the time we're done, he has checked in this.
The third review.
I swear to God, I have seen this API at least 4 times at this point.
Should we call it max or maximum?
Movie Bike Shed, can somebody summarize what was the feedback last time again?
It's not in here, but it's
okay, it's not in here. Never mind.
Feedback was to add decode and encode in front of UTF-8.
If you look, if you go to the original post.
Yeah.
But it's not to UTF-8, it's to ASCII.
You like that better than UTF-8. But whatever.
We might set up a special meeting for you next time in different office. Asking. Go asking.
So the feedback from last one of the things that I brought up was I thought that we could get away with having rules instead of operation status. We all discussed this amongst the team, and I think our conclusion was we'll just leave it as operation status, because that way the caller can, it's not incorrect to do that, and the caller, if he really wants to know about the different conditions, can take different actions based on it.
Common name for ASCII and UTF-8.
So ASCII is ASCII.
I know.
Oh, there's blinks.
Maybe it should be like single byte encoding. Yeah, well, I guess it's okay. People will have to know that it's actually ASCII.
So you can go to the original, the first post. One of the questions I had was for decode. Do we need for symmetry with encode in place, do we need the data length? Because you could.
You need what? Sorry.
The data length parameter, because that is unnecessary for decode in place, but I added it for symmetry with encode in place. You could go without it.
So I would not have it. I think the the pattern that we should have is static methods are specialized for the operations, and there should be like nice, set of APIs for the particular operation. And then we have some abstractions, and yes, abstractions will have some parameters that maybe don't make sense, but you still pass whatever you have.
Okay.
So like, there will be, at some point we're gonna return transform operation, or whatever we call this thing. And then, yes, it will have this parameter.
So does that mean that is final block should actually be at padding rather than is final block?
No. I think the way to think about this is that we should not reshape the parameters. We should just leave things out that are nonsensical.
Okay.
Because otherwise it will be very hard to go from the abstraction to the concrete ones or the other way around.
Okay. Sure.
But I think we should have the same concepts, just you tailor them and remove concepts that don't apply.
And also the user they know that it's a final block, but they don't understand the padding because they don't have to understand the format, actually.
Yeah.
So one other piece of feedback that I had from last week that we started talking about was what do all of the different operation status return codes mean? And there's obviously, the behavior of the API is obviously, falls under the umbrella of API review. And what values do the out parameters have for each given operation status that can be returned? And I think you actually, Asan, I think you answered a lot of that in the comments. The only one that I still had questions on was invalid data. Because I think I could make an argument that if the operation status is invalid data, like the consumed and written parameters are just completely meaningless.
In general? Or
in general, yeah.
Or these specific APIs?
In general. So if I piggyback off of what Amos said, like if this returns operation status, then it should have the same behavior that any transform that returns operation status should have, at least as far as populating those two out parameters. And I was wondering if, say that you're passing is final block true, and you're passing input data that's not an even multiple of 4 bytes, there is no way whatsoever for that data to be valid. Why would the decode method even try processing it?
Because it's unnecessary to do that check for the invalid case to hurt performance for the valid case. Why would you add that check? Like, why would you add that logic when it's like a corner case that you want to address in the mainline scenario?
Basically, so I'm not necessarily thinking about base64 here, but one of the APIs that I'm working on is URL decoders. And it would be, one of the checks that I have to do is this valid UTF-8 data even coming into the system? It would be great for me to just do a check up front that says, are you valid, yes or no? If no, just fail.
Okay.
Rather than having to iterate through every single possible character and then check, well, I know that there's invalid data later in the string, but maybe I can start doing %unescaped.
I mean, you can still bail, but your check for is invalid data will return you the index of invalid. You can just return that.
No, but the problem is, like, if the contract here is that you have to have done work up to the point where the invalid data occurs, this means that the logic for at least the URL decoder now becomes amazingly convoluted, because I have to keep track of where the UTF data is invalid versus where it's valid, but I still need to do work. And now I just need to keep like 3 different indexes in place inside the implementation. Whereas if the behavior were just, if you see invalid data, don't bother populating those 2 out parameters, just say default, it makes the decoder logic very simple. Hopefully that all makes sense. Also because the caller can't really recover from invalid UTF-8 or invalid base64 data. Like, what if we return invalid data, what is the caller expected to do? Like, he's going to have to fail.
Right, but you at one point you bring the general concern, which is the opinion channel's invalid data should apply, the behavior should apply for all transformations.
Yes.
And then you argue that with specifically the base34 invalid data and everything.
So I'll give you a scenario where the caller does not have to fail.
Yeah.
So let's say you're writing a diagnostics tool. You may want to get as much as you can, decode it, and then show people that at this index something went wrong.
But so you're saying because the caller might have a diagnostics tool, we're now placing a requirement on every transform that will ever be written and every API that can ever return operation status that they have to go all the way up until the point of failure.
Well, so initially the reason for this behavior was that we wanted to implement transcoding,
yes,
fallback.
And I argue this is actually the wrong place for that. So you should take a fallback decoder as a priority.
So we could decide that we don't basically we have built-in fallbacks.
Yeah. Mainly because I don't think the caller is ever going to.
And then we don't, then frankly we can even probably throw if there's invalid data. Well, maybe not.
Well, I mean, I think the question is more what do you, what semantics do you want? I mean, if you look at other examples of parsing, I mean, for the most part, you want to continue parsing if you can, because it's usually better to return something.
For UTF-8 parsing, I would agree with that. For anything else, I wouldn't. Like, what does it mean to skip over a chunk of bad base64 data?
Depends on what you're parsing. I mean, there are enough scenarios where you just have to parse, stuff where it's not necessarily complete or well-formed, and you just, the caller just ignores that chunk of the data and says, yep, this part of the message has been garbled, so I cannot make sense of that. But
but the problem is, again, imagine base64. There's a difference between, say that one byte just got flipped on the wire,
right.
You lose that chunk of 4 input bytes, 3 output bytes.
Yep.
So you have 3 bad output bytes in the data.
Yep.
Versus a byte was dropped on the wire, which means all data from here on out is completely dropped.
Right. But some of this you can't detect anyway, right? Some of this will just return wrong data, but we didn't know it's wrong, right? Depending on what the encoding ends up being, right?
Yeah, but I'm wondering how the caller could possibly make that distinction.
Well, I'm saying, depending on the format, even the encoder may not be able to make the distinction, right? Because the format looks valid. It's just garbled data.
Yeah.
I mean, what would be the alternative? The alternative would be we throw, or...
No. It returns invalid data and sets consumed and written to be default 0.
But is there a benefit? So what you're saying? What's the benefit of it?
The benefit of it is you don't place a requirement on every possible implementation of transform to have the behavior where it needs to go all the way up until the data is bad. If the transform can detect ahead of time that the data is bad,
sure.
Maybe just by doing
so let's not put the requirements. Basically, when invalid data is returned, they can, consumed and written can be 0 or can be as much as they actually decoded. If they can check ahead of time and return 0, then sure, they can do it.
But this also means that consumed is no longer an index into where the data was bad. And you seem to be relying on that.
Why it's not an index?
Because if, again, imagine decode from UTF-8 where the input is 11 bytes, and it just returns invalid, consume 0, written 0. Does the invalid data start at position 0?
I see you saying that returning 0 would imply that the first byte was invalid, but sometimes it's not the first byte, but
what I don't want is for consumed to point to where the invalid data was, because A, I don't think it's always possible to detect, and B, I don't see how the caller could use that information.
The only thing I could imagine is if you write a parsing tool, right, you can just point to the location in the buffer, right, and then for diagnostic information you can say it'll still be okay, because basically what it means is if I parse a ton of data, I can go over a ton of the headers, and then I can say, well, somewhere here is where the whole thing went bad.
Yeah.
And in your case, it may be the start of the buffer, in my case, it may be the middle of the buffer, but are you proposing that you always have to return 0, or are you saying 0 should be valid if I detect it up front, which I will be okay with?
What I'm saying is 0 should be valid if it detected upfront, but otherwise we shouldn't start placing requirements on how the transforms work.
So what about you call this operation, invalid data is returned, output that slice 0 to written is as much as I could decode.
That's what it is now.
That's what it is now.
So so like a debugger can show basically.
Yeah, that's what it is right now.
Yeah.
That's what it is right now.
Which I think in your case would still work, because you said, I know that my input size has been a multiple of 4. You gave me something that is not that, so I just bailed on the first byte. Yeah. Which still seems fine, because you didn't try, right? Like you still adhere to what the says.
So then if written is valid, basically, I wrote that much to a buffer, then consume this. How much did I have to consume to write as much as I wrote?
Yeah, I'm okay with that, but what I don't think we can say is that it's now a requirement for all transforms to try to go as far as I can.
That's fine.
And I don't think we should say that consumed is supposed to point to the first invalid value.
I would say that consumed is related to written.
Yes.
Right. Which basically is how much I consume to write what I wrote.
Yeah. I would be okay with that.
Yeah. But then let's say your encoder reads in 4K chunks.
Yeah.
But it only has written 8 bytes. Is that okay?
I think that would be a stateful decoder instead of a stateless one. Which we're not really considering here.
I guess is fair in this case.
Yeah.
Yes.
What's the decision? I don't understand the decision between the consume pointing to the first invalid byte versus consume pointing to how much was consumed to write.
Even with base64 decode, consume doesn't point to the first invalid byte.
Yeah, exactly. Right. I think that's a good point. Basically, consume doesn't point to the place where the problem is.
It just says how much was consumed.
It just says how much successfully was.
No, not even successfully. It just means that this is how much you consume before you decided to bail. But like you may have written 60 bytes, but from the 60 bytes you did something with the first 32 to decide that it's invalid. Right? Like then 32 is lost.
I think it makes sense for consumed and written to be married, like you were suggesting.
Yeah.
But yeah.
I think in general, like in practice, we talk about binary formats, right? Like if even let's say even you can pinpoint the exact byte where your encoder decides the data is not invalid, it's not very likely that is the root cause, right? It's somewhere before or somewhere after, depending on like whether you look ahead to make decisions or anything like that. I mean, like you just get a vicinity where the error is likely to be, right? And then that's basically the granularity of whatever that guy reads, like how big the chunks are that this guy reads, right? Which
so,
may be okay.
So is the requirement still that there'll be some partial work done?
No, that I was trying to eliminate that as a requirement.
But then with contract that Christoph's mentioning that the output or slice to written has the partial work, right?
If you perform partial work,
then
those two parameters contain where the partial work was done.
Gotcha.
But there's no requirement that implementers actually did any partial work.
Gotcha.
Yeah.
Which just still seems fine. I mean,
Sure.
Yeah, I think having an exact requirement would only make sense if the caller could do error recovery, right? But you all agree that you can't. Right? So
the thing is, like for an individual API on a static method, I generally wouldn't care about this. But because in particular this returns operation status, the operation status enum has to have well-defined behavior with how any API that returns it populates its out parameters. Otherwise, it's going to be too difficult to consume the enum.
sorry, I didn't quite understand what you mean by that.
So basically, any API that returns this enum has to have a structure to how it passes the other out parameters, such as consumed and written. Like I don't think we should have a separate behavior just for this static API that's different than what we would expect an iTransform to provide.
Yeah, I'm not sure what you mean by structure. Like, do you mean like the values that it sets to based on the reserved value of the enum, or just the structure in the API, like how many you accept?
The behavior, really. Okay. When I say structure, behavior.
Okay. I mean, what is a problem is that with the all parameter, like you like it will essentially override the values in all cases, right? Because because it's out, it has to provide the value every single time you call it.
Yeah.
Which means if you want to keep track of what you did yourself, and this way always sets it to zeros, then you need to do some copies before. But like that's just the way the out
But
parameters
out
work.
parameter cannot be assigned before you call it, so it is the default.
No, it can't. Yeah, it can. Yeah. It just means you double assignment. I mean, usually the common pattern is you have a variable in a loop, and you reset it at every iteration, but the variable can be declared outside the loop, right? Yeah. So it has
No, you're right. You're right. Yeah, yeah. Mm-hmm.
It's totally fine to have that.
Yeah.
Yeah.
It just means you're losing that value every single time you call it. Like,
you don't have to initialize it.
Yes, you don't have to initialize it.
Yeah.
That's right. All right. So then, any other concerns with the API? I think last time the only other feedback that we gave you was think about whether the enum is used at all, and I guess you concluded that it is.
Were we going to walk through a set of sample code of usage of what this loop look like, this magic loop you're talking about?
Well, that was basically when you guys decided that not to have that, then that would have been required. I guess you did this and you concluded that the code is too convoluted, or?
I personally, I still think operation status is unnecessary, but I'm willing to see the argument.
It would help to see the actual code, I guess.
All right, go to there's actually a code sample.
Where is it?
Go to prefix lab.
Oh, is that the one again where you only remember the URL?
Where is that sample? Yeah. I only remember how to get there.
But that sample code doesn't use these APIs as they're defined, does it?
Well, but it shows how in base 64 encoding operation status. So go to Azure Experimental.
With Azure?
No, go to, sorry, Buffers Experimental.
Okay.
Go to System, Buffers, Span Writer, and then
in the
don't,
PR.
you're scrolling too fast.
Sorry.
I'll link to it in the PR, in the issue.
If you go,
Go to the original post, link details.
Not see.
No.
Oh, that one.
No, there's a link on the top.
Oh,
Details.
this.
Scroll down. Sorry. It's you have to go up. Go up. Yeah. For example, Span Writer.
Oh, I see. And I have to say, this code is pretty nice. If I logically in my head have to replace the checks with the operation with like some convoluted less than and greater than, that seems harder.
No. The sample code that again, I don't know if we want to rat hole on this because I conceded the argument that that operation status is fine, but the sample code that I had no comparison terms whatsoever.
So how would you write that code then, just for the sake of argument?
I would always make sure that resize were called before I call transform. That way, the output
of this, which means that this is basically only done or not done, right?
Yeah, it has either succeeded entirely or it has not. But if it has not succeeded entirely, that means something went wrong and failed.
So how do you know then? How do you differentiate between I am done and I have no more data and it was invalid?
I am done means all of the data was valid. Any other return code whatsoever means either the data was invalid because it was incomplete, or the output buffer was too small, but it couldn't be too small because I resized it ahead of time. So if it returns true, you're done. If it returns false, you're done.
Oh, because in your case, false means, like, in your case, if everything succeeds, the method always return true even on the last one. And you just know you're done because you exceeded your input buffer.
Right.
And so false will always mean error.
Yes.
So you basically conflate 2 into
So
3 into
in my opinion, the issue with this solution is that resizing ahead of time, I think, ranges from it's not optimal to it doesn't work in some cases. Because if the resizing, if the method to measure was precise, it would work.
Yeah.
But given that it's not precise, you may end up in a situation where you kind of resizing too much, or you ending up with a worse situation where you
Right. So the
where
idea,
in fact it's not too small because the resize overestimates.
the idea is that the resize allocate, or the resize resizes to the worst possible output, the largest possible output. And you're right, it does sometimes overestimate, but it also makes sure that it can hold absolute. And if for whatever reason you can't resize, just try the operation anyway. If it fails, it fails.
Well, but then we don't have. It's not about. Like I would have to call the measure, then like the algorithm is generic, so I don't know whether I can resize or not. I mean, it's.
Well, if you can't resize it, you just skip the resize step, and you just try working with the buffer you have. It'll either succeed or it won't.
No, I'm saying this resize is a callback. I don't know what's inside resize. It may resize or it may not resize. Because the writer
again,
is...
just keep the operation status, like it makes code like this one.
Right.
Then I add the feedback for removing data length from decode in place.
Sorry, what was that?
Decode in place, I added in data length for consistency. You said we don't need it.
Oh, okay. Decode in place, yeah.
Because it always shrinks.
Yes.
So any shrinking transformation, we shouldn't add the data length.
Right.
So is it okay to remove that out consumed as well? Like we had initially, we would return how much we consumed.
Right.
And how much we did grow.
So we never
really
decode in place partial data.
Right. Exactly.
Are you sure?
Yeah, that's the contract. It's like it's going to be one shot. That's why we don't have the final block either.
Well, for the debugging scenarios, you may want to decode partial. Show how much you decoded.
Do you?
I don't have a very strong opinion. I'm just saying, if you wanted to write a diagnostic tool, it could be useful. But you could also use if you're writing the diagnostics tool, you could. Yeah, I don't feel strongly either way.
So basically, I think this one here was we don't need those.
No, you need,
that's fine.
You need it.
Yeah, you need that.
But you don't need
the
this.
one beneath it. You don't
Decode
need.
you don't need.
Yeah.
Just the in data length.
So you don't need that. Is that what you're saying?
Yeah.
Right.
That's it.
I see.
Because decode would shrink whatever's in the input buffer.
Right.
Whereas encode expands, so you need to have slack in the buffer.
Now, if you had an interface, like an iTransform interface, that were an abstraction around this, you would have the length method on the interface. And it would just internally slice the span before it hands it back.
What's your alias, by the way, on GitHub?
Grab.
Oh, grab your pitchforks, yeah.
Fourth one.
Oh, Jesus.
Come on, you have your fancy tooling.
How do I spell it?
CEDE. Yeah.
Oh, okay, so it actually makes no sense. The English never makes sense. It should.
Don't they have a plugin for statement completion when you write English?
So it's just a Markov generator?
No, like on the phone, when you start typing, it completes. Autocomplete. There should be something like this for browsers.
But then it's going to be a learning heuristic, and then we're going to see what Emo, types in his spare time.
Probably involves a decent amount of swear words. All right.
Mark is approved.
Anything else? Otherwise, lunchtime.
Very much. Yeah.
Just give you
Needs work.
Still needs work. 5th round.
So this is in system memory also?
For the time being.
Because we basically decided it doesn't make sense to break the features into too many DLLs. They are relatively small. The only thing that would make sense is break span out of all the methods that operate on span. But we need to decide it separately.
What about the purely you conversation?
Yeah, that's the one.
Oh, I see.
Like if we decide to have permanent OOP, we would also put all the methods in one permanent OOP, not in 20 permanent OOPs.
All right. I think we have discussed the OOP thing. Yeah. All right. Thanks, guys.
Thank you.